Hi, my name is Kaya Gallagher, and I have been working with my mentor, Dr. Reed Nelson, researching divergent migratory behavior of local river herring. Due to a concerning population decline of river herring species in the Virginia area in recent decades, a moratorium in the state has been set in place since 2012. The fish used in this project were collected between 2016 and 2022 by the Potomac Environmental Research and Education Center during their spring spawning season from 3 tributary streams of the Potomac River: Accoting Creek, Pohick Creek, and Cameron Run. I started by dissecting 81 total river herring, 49 alewife, and 32 blueback herring. This process includes weighing the fish in their gonads and removing their otoliths. Otoliths are calcium carbonate structures known as ear stones that can be used as natural chemical tags to track a variety of fish movements, including migration. Otoliths were extracted by slicing open the top of the head to expose the brain case and removing any necessary brain matter in the way to expose the inner ear. I removed the pair of sagittal otoliths, which are the largest of the 3 types of otoliths that these fish possess. An otolith from each fish was then cleaned, set into epoxy, and sectioned using a precision sectioning saw to expose the core for transection. After being polished with sandpaper, they were then affixed to glass microscope slides using superglue and analyzed via laser ablation inductively coupled plasma mass spectrometry. River herring are anadromous, so they spend a majority of their lives at sea and travel to freshwater to spawn. The incremental growth structure of otoliths allow for a chronological investigation of the environmental conditions of their surroundings. By analyzing the microchemistry of these otoliths, elemental ratio data can be used to infer lifetime migratory histories across salinity gradients. Using barium calcium values, strontium calcium values, and manganese calcium values, I generated plots of lifetime percentages, the proportion of life spent in different types of water, in low salinity freshwater, estuarine water, and high salinity marine water, for each individual. The cutoffs for the values I used were taken from research done in 2016 by Limburg and Turner. Using the data gathered over the course of the project, I have been able to see a lot of varied lifetime migration trends and size of estuarine egress for these fish. For example, alewife 4 looks to have some abnormal migratory life history. As you can see, its marine levels are at 0, which indicates that this individual may have never migrated into fully marine waters.